Now, see, we have to discuss the refraction through spherical surfaces. Refraction through spherical surfaces means we are now going to the mathematical portion of it. Okay, but before I will be discussing 3-4 cases, right? But before I discuss here these things, I want to make some important assumptions. Let us first make some important assumptions. You can write assumptions. Number 1, first assumption. For discussing this mathematical portion, I am using some important assumptions. First assumption is the object is a point object placed on the principal axis. The object is a point object and placed on the principal axis. Very clear. Object is a point object placed on the principal axis. Second point. The aperture of the refracting surface is very small. Which one is aperture? Here is the aperture. Suppose from O, the ray is falling at this point. Let us say this point is A. Then PA or AP, this portion is the aperture. So, aperture of the refracting surface is very small. Aperture of the refracting surface is very small. And number 3, angles made by incident ray, angles made by the incident ray, refracted ray and the normal. Angles made by the incident ray, refracted ray and the normal are also normal with the principal axis are very small. I repeat, angles made by incident ray, refracted ray and the normal with the principal axis are very small. This is alpha, this is beta, this is gamma. These are the 3 assumptions. These are also very small. These angles are small. But before I proceed in the further cases, I first tell you I am discussing it under the 2 heads. Okay, पहला हेड जो होगा वो यहाँ पे assumptions हो गया. अब मैं सबसे पहले करूंगा for the convex surface. Okay, I better here I write A. Try to follow me. I am first doing it for the convex refracting surfaces. You all know what is the structure for the convex refracting surfaces. This is the convex refracting surface. Okay, and in this I will discuss 3 cases for the convex. For the convex, number 1 convex, 3 cases. A, first case A. Object is placed in the rarer medium mu1, and the real image is formed in the denser medium. Look at the topic of it. Object is placed in the rarer medium and the real image, its real image is formed in the denser medium. Alright, let us first see the image formation. Here is the convex surface, mu1 and mu2. This is the rarer medium, the denser medium, principal axis. O is the point object. From point object a ray travels, falls at the point A is the point of incidence, thereby refracts, bends towards the normal. Normal मैंने कहाँ draw किया? A point पर मैंने draw किया. From the point N I have drawn a normal that is coming to the point C. C is the center of curvature. Because you see, normal का मतलब क्या? It is normal to the tangent at this point. Whenever we are drawing a normal on a curved surface, means at that particular point, if you have a tangent, it is normal to that tangent, isn't it? So it is coming to the point C, meeting at the point C. C is the center of curvature. It is the radial direction, center of curvature. It bends towards the normal and it is meeting at the point I. Here, what will happen? A ray, although I am not showing, this is the principal axis. Along the principal axis also a ray will be traveling straight, perpendicularly, normal incidence. Both the rays will be meeting here. You know, real image is always formed due to the real intersection of the rays. Here the real image is formed. That means, can we say from pole to this is u is the object distance. From here it is r is the radius of curvature, and this is v, image distance. These things we are getting now. What we shall do? We shall apply here now geometry. Take this angle will be I, this angle will be R, okay, angle of incidence, angle of refraction. Now you take the triangle, which one? AO, here it is triangle AOC. Let us take the triangle AOC. I is equal to alpha plus gamma. I is equal to alpha plus gamma. I is equal to alpha plus gamma. These are the two interior angles. Exterior angle. I is equal to alpha plus gamma. Now it is equal to tan alpha plus tan gamma. Why? For small angles. Because we have already considered alpha, beta, gamma as the small angles. Alpha by the incident ray, beta refracted ray, gamma normal with the principal axis. Now tan, to find out tan, definitely I have to drop a perpendicular. Let us say Q is the foot of the perpendicular. Fine. Then what we shall get? I should be equal to tan alpha must be, see the figure, AQ by QO plus tan gamma AQ by QC. AQ by QO by plus AQ by QC. Now you take the right angle triangle. Now you take the triangle AIC. Gamma is equal to R plus beta, which means R is equal to gamma minus beta. So R is equal to, what is this? Is gamma minus beta means tan gamma minus tan beta. So tan gamma is AQ by QC minus tan beta is AQ by QI. Right, these two angles correlation we have seen. After that let us apply Snell's law. How to apply Snell's law? Rays traveling from mu1 to mu2, refractive index of the denser with respect to the rarer should be sin I by sin R. Mu2 by mu1 is equal to sin I by sin R. But if the aperture will be very small, what is meant by the aperture is very small? Means portion AP will be very small. You just imagine, if the portion AP becomes very small, I will become very small, okay, and R will also become very small. So what will happen? Here I will write, it is equal to simply I by R. I will write for small aperture AP angles I and R are very small. So how much we shall get? Then sin I by sin R is equal to I by R for small angles. Then mu2 into R is equal to mu1 into I. What is mu2? Look, what is mu2? mu2 into R की जगह पर AQ by QC minus AQ by QY equal to mu1 times. I will write here I की जगह AQ by QO plus AQ by QC. From both the sides, AQ will be cancelled. So mu 2 1 by QC minus 1 by QI is equal to mu 1 1 by QO plus 1 by QC. Alright. Now, for small aperture, P and Q are too close for the small aperture. If the aperture is very small, right? For small aperture, what will happen? P and Q are too close. Okay? For small aperture, P and Q are too close. So mu 2 1 by, in place of QC I will write PC minus 1 by PI is equal to mu 1 1 by PO plus 1 by PC. In place of Q I will write P because P and Q are too close. So now apply sign convention, which is the direction of the incident ray from left to right. So all measurements in the direction of the incident ray will be positive. So according to sign convention, 1 by capital R minus R will be positive. R will be positive. 1 by V, that is also positive. Mu 1. 1 by minus O because it is negative, and plus 1 by R. And you just check whether what you are getting, mu 2 by V minus mu 1 by U. Mu 1 by U is equal to mu 2 minus mu 1 by R. Look, what we are getting, just see, mu 2 by V minus mu 1 by U. Do you rearrange it? Shall we get mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. This is the formula, established formula I am getting in the first case. Okay, just see here. This is the derivation for the first case. Alright.